In many places around the world, and even in local areas, clean water is a difficult resource to come by. With the increased presence of pollutants and contaminants, the ability to filter water is more important than ever. Thus, it is the objective of this design to create an off-grid water filter that is solar-powered and transportable, allowing users to use the filter in all types of scenarios. The filter will be able to monitor its own health and produce water that is cleansed of the majority of waterborne contaminants. The design will also be within a designated budget of $230.
We're starting off with our system. We have water located from Clear Creek, completely nasty.
So, as a first step filtration, we have a mesh at the input of the tube to get rid of any larger particles like rocks, wood chips, any greenery. And then a second step is a 0.5 micron filter to get rid of any smaller bacterial contaminants that may be in the water.
So the water goes, after it reaches our first stage filter, goes through the tube into the pump, and then through a check valve into our filter. And then from our filter, it comes out, around, and through a flow sensor into another check valve. Between the required pressure to crack each of these, we end up at just about atmospheric. We added a spout here to allow air to escape so that we don't build up pressure in the system. And then as it comes out, it goes through another flow sensor into the spigot.
All right, so for the housing for our prototype, we originally were going to go with a more of a backpack design, but based on the sizes of the battery, flow, filter, and everything, we decided it would be more suitable to go for a bigger box. So within the box, there's multiple hole cutouts for where items are placed, such as the button, switch.
Transitioning really quick to our circuitry. As you can see, we have a solar panel up front that plugs into a PWM voltage modulator over here, which controls voltage that comes from the battery, as well as also charges our battery. We have an Arduino that is in charge of handling all of our actual circuitry. It's the brain of our circuitry. And we got a DC-DC step down from 12 volts to 7.5 so that we can actually power our Arduino. Arduino is in charge of collecting data from our flow sensors and also controlling our relay, which activates the pump.
The primary objective of this design was to filter out the majority of waterborne contaminants. With a 0.5 micron filter, the water being output by the design is significantly cleaner than the water being input. Testing has also verified the achievement of this objective. The solar panel located on the outside of the door provides sufficient power to charge the battery on the inside wall of the system, allowing the design to be self-sufficient in off-grid scenarios. The presence of the LED on the outside of the housing correctly exhibits the status of the filter, continuously monitoring its health. The cost of each part is outlined in this bill of materials, and it is evident that the manufacturer of the design does not exceed the designated budget. Here we are ensuring the efficiency of flow matches the criteria set early on. It is important to note that we can visibly see that the weight and size of the design is still conducive of being transported. Further, we can see that the system took 1.3 minutes to produce a gallon, which is an efficient filtration rate.
For future considerations, we would change the circuitry. Instead of being a jumble of wires, we would switch to a PCB so that it's a lot cleaner and easier to actually use and set up so that it's less likely to short circuit. We would also need to take into more careful consideration to ensure that the circuitry does not blow up because of lack of fuses or resistors. So we would add some fuses to ensure that it has some safer areas to fail than what previously happened.
Also, for future considerations for the housing, we would not be making this out of plywood. This would be made out of some sort of PLA, ABS sort of plastic, as it would be much more sustainable in off-grid scenarios.
For future improvements, we would put handles on the side. This would be easier for transportation. We would fix the leak that happens between our container and our flow sensor.